Yo, 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 this is Mr. O. Yo, 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 this is Mr. O. And today we're going to learn about inverse function. How to identify if the two functions are inverses of each other. Okay? And let's say we are given two functions. If f of x equal to 2x, g of x is equal to x minus 3, is f of x the inverse function of g of x? There are two ways. First, we have to use the composite or the definition of f of g of x. If f of g of x is equal to x, then they're inverses of each other. So let's say f of g of x. So f of g of x, that means the g of x will go to the x of f. So f of x minus 3, and I'm going to plug in the x minus 3 to the x on the f of x, which is 2x. So 2x minus 3. Distribute the 2x minus 6, and you cannot combine them. Since this one here is not equal to x, the answer is no. They are not inverses of each other. Okay? Another way of doing this is that you can try to find the inverse of f of x. If you try to find the inverse of f of x, we know that f of x equal to 2x. So replace the f of x by y equals 2x. Switch the x and the y, so the y becomes x and the x becomes y, and we solve the y from here. Divide by 2, divide by 2. So we know now that y is equal to x over 2, or the inverse of f of x with the negative 1 on top of the f is equal to x over 2. Is this equal to the other function? They're not the same. So the answer is no. Next, if f of x is x plus 4 and g of x x minus 4, is f of x the inverse of g of x? Let's find out. So let's try to do the f of g of x. If this is equal to x, then they are inverses of each other. If not, then it's not. They're not inverses. So f of g of x, that means whatever the g of x, which is here, will go inside or will replace the x on the f of x. So therefore, f of x minus 4 will be punched in or replace the x to the x plus 4. So this will be now x minus 4 plus 4. What's negative 4 plus 4? That will be 0. Let's cancel out. So what's left here is just x, which is just x. That's the definition. So therefore, the answer here is yes. F of x is the inverse of g of x. And the other way is, let's find the inverse of f of x. We know that f of x is x plus 4. We replace the f of x by y, x plus 4 here. Swap the x and the y. This y becomes x, and the x becomes y plus 4. Let's solve for the y here by subtracting 4. And we know this will be y is equal to x minus 4. And we can replace the y by inverse of f of x. That becomes now x minus 4. We can say that this one here is same thing as the g of x, so therefore they're inverses of each other. Let's try this problem here. Is g of x the inverse of f of x? So we can plug in this right there, or vice versa. We can plug this in to the x there. That's the definition of g of f of x. This time, if you notice, I'm starting with g of f of x. A while ago, I did f of g of x. It's the same thing. It doesn't matter as long as the answer will be just x. So for this example, I'm going to try to plug in the f of x to the x of g of x. So therefore, the x cubed minus 2, I will plug this in right there. So it will be g of f of x, and then the f of x, the cube root of x plus 2, will be plugged into the x of g. So this will be cube root of x plus 2, and then there's a third power there, minus 2. We know that the cube root and the cube will cancel out. So what will be left there is x plus 2 minus 2. And this will cancel. So what's left with us is just x. So therefore, it's a yes. They are inverses of each other. Okay. Is f of x the inverse of g of x? This time, let's try to plug in the g of x inside of that, of the square root of x. So this is f of g of x. Again, it doesn't really matter if it's f of g or g of f, as long as it's equal to x. So this is f of g of x. Then the g of x will is 4x squared plus 5. You're going to punch it inside the square root of x. So square root of 4x squared plus 5. I don't think you can still simplify it because there's a plus here. And I don't think this will be equal to x. So the answer is no. How do you find the values of the inverse of the function from a table? Remember that inverse function, you swap the x and the y. Okay, the function f of x is invertible. Find the inverse of f of negative 21. So here we're gonna look for the negative 21 on the y value on the fx, which is negative 21, and the answer, the corresponding x, is negative 5. So the answer for inverse of f of negative 21 is negative 5. The function fx is invertible. Find the inverse of f of negative 3. So the negative 3 on the y, we're going to find the value of x. The answer here is 0. The function fx is invertible. Find inverse of f of 5, the 5 of the y, and the answer there is, the value of x there is 3. Okay, very simple, right? Now let's find the value of the inverse of the function from graphs. Okay, the function fx is invertible. Find the inverse of f of 9. Take note that the 9 that we're looking for here is coming from the y value on our graph. Okay, not on the x. Same thing with the table. We always look at from the y. Why is it so? We normally do it on the x, but because here is inverse, we swap them. Okay, so the x becomes y, the y becomes x. So here we go to the 9 of the y. This is the 9. And look where the graph cross is, right there, that point there. In this case here, it is negative 5 comma 9. That's the negative 5 right there. So therefore, the inverse of f of 9, it's negative 5. The function f of x is invertible. Find the inverse of f of negative 2. Go to the negative 2 of the y right here. And that point there is 0, negative 2. And the value of x there is 0. So this one here is 0. And for our last example, find the inverse of f of negative 2. Go to negative 2 of the x of the y, and the graph is this green point here. That is 1 comma negative 2. So therefore, the value of y here is 1. There you have it. I hope you learned something. As always, kaboom.